Hello everyone, today we'll be looking at this Leetcode problem. It's a little more complicated than the last one, and I'm really unhappy with this solution, so if someone has a better solution, please let me know. Okay, so I start with sorting the input and filtering for positive numbers, which happens right here. I then calculate the iota with the length of the input array and calculate the difference array, which I'll use a bit later. I then use the difference array to grab an array of elements that are different from the iota, but I left shift the difference array first, which I'll explain later as well. And then I have a pretty nasty set of nested expressions here. First, if the length of the sorted and filtered input array is 0, then all the numbers were negative or the input list was empty, and either way the first positive value is 1. Otherwise, if the first element in the sorted filtered input is greater than 1, we can also just return 1. Otherwise, if the sum reduction of the difference array is 0, then our input was the same as our iota, and the next positive number is just 1 plus the length of the input, the next natural number. Otherwise, our answer will be the number that came before the first number in our input that was different from our iota plus 1. That's why I had to shift this difference array. And the rest of the code outside this function is just used to make the results look pretty, so let's go ahead and run it and see what we get. Perfect, the answers match our actual results, so let's move on to the GPU-enabled C++ version. This solution is a bit more complicated and it may require some knowledge of how C++ and GPUs work in general. You can see I have the BQN solution in the comments up here, and the first thing I do is set up my Umpire resource manager for memory allocation, and I have my answers in a 2D vector right here. For each test case, I allocate my array in unified virtual memory and copy the data from the test case. I then sort the input just like in the BQN solution, and then I perform a filter, also just like the BQN solution, but it's quite a bit more complicated to perform on the GPU. I first create a mask which represents all of the elements of the input array that are positive, and I keep a running tally of the positive elements so I know what my new length will be. Then I perform a sum scan, which gives me the indices in the final array that each element should be placed in. I then reassign all the values of the array to their new locations after they've been filtered. And then I reassign n to be the new length of the filtered array. I then deallocate the memory I used in this block. Let's go over this again really quickly with a graphical depiction. Here we start with one of our test cases. We create a mask based on the predicate greater than 0. We then sum scan to get the indices in the destination array. And then for each element, if the corresponding value in the mask is set, we place the original values in the new destination based on the indices array. So this element will go to position 0, this element will go to position 1, this element will go to position 2. If everything in the previous step was filtered out, or if the first element is greater than 1, then we can just return 1 and call it a day. Next, I calculate a difference array which contains the difference between the elements of the filtered input array and the iota of the same length. After that, I perform a sum reduction to see if there are any differences. If there was no difference between the filtered input and the iota, then we can just return the next natural number, or n plus 1. If that's not the case, we'll have to find the first number that differs from the iota and add 1 to the number that came before that number, in case our input array skipped multiple numbers. And that's the end. I just deallocate my memory and print out the answers that I got. Let's build this code and see what we get. And look at that, we got the same answers that we got from our BQN solution. Well, this is everything. I hope you all found this interesting. Please let me know if you have a better BQN solution or if you have ideas for future videos. Thanks. Bye.